merge sort, quick sort, heap sort, radix sort, count sort, binary search, and median search. So these are the various topics that we are going to cover in module 1. So we will start with the module 1 today. So what is an algorithm? Who will tell me? Yes, who will tell me what is an algorithm? How do you define an algorithm?
Ma'am, these are the steps to do a particular problem, to complete a particular problem,
To solve a particular problem.
solve a particular problem. Yes,
Yes,
ma'am.
algorithm is basically a combination or a sequence of steps which are required to solve a particular problem. Or you can say it is a computational procedure that takes some value as input and produces some value or a set of values as the output. So it is basically a sequence. We say algorithm is nothing but a recipe, isn't it? So recipe, like if I tell you to tell me the recipe of the how to make tea, so in that case what are the steps you are going to take? So making a tea, that is some problem that you're trying to solve. That means some task that you have to do. So what is the task? That you have to make the tea, and how are you going to do that particular task? So how is answered by the algorithm. That means how means what are the steps that we are going to take in order to solve that particular problem. So that is a finite sequence of steps. We cannot have an infinite sequence of steps for solving a particular problem. So we have to stop when we have found the solution. When the tea is ready, we have to stop. We have to serve. So here also, when you can say when the problem is solved, when the problem is solved, we have to stop that particular writing the steps, right? So we say it is a well-defined computational procedure that takes certain input and then returns certain output, and this output may be a single value or multiple values. Similarly, the input may be single value or the multiple values. Like the task of sorting, like if you are given the task of sorting, you are given certain numbers, let us say 10, 30, 50, 78, 98. You are given 5 or 6 numbers, and now I tell you to sort these numbers. So for sorting these numbers, you will be writing certain steps, right? So whatever steps you are writing, that is called as the algorithm. And when we talk in the generic terms, let us say A, B, C, D, E, F. These are the 5 numbers, and when we assign the certain values to these numbers, like A, B, C, D, E, F, these are the general values, general terms, and I'm assigning certain values like 78, 25, 34, 19, 15. So these are the values which are assigned to these alphabets. So I say the values which are assigned to these generic terms, they are basically the instances of these terms. So you can say this is called the instance of an algorithm, that is the input to that algorithm at a particular instant of time. So we are trying to solve the particular problem using certain algorithm, and for that, for at a particular instant, the input to that algorithm is called as the instance for that particular algorithm. Now, when we say this input is called the instance of the sorting algorithm, so which algorithm is best? Like all of you have studied about the what are the various sorting algorithms. So can you tell what are the various parameters on which the performance of the algorithm depends? Yes, please. Who will tell me that the various parameters
Time and space.
Diamonds.
besides that? So time and see, time and space also depends on something, no? Yes, number of comparisons is fine. So the number of comparisons, see, if we are coming, so you're coming from the bottom to top. So we said time and space complexity. Then from time and space complexity depends upon the number of comparisons. And the number of comparisons ultimately depends upon the kind of input that we have received. Isn't it? So the kind of input means how many numbers are there that we need to sort. Are these the small numbers? Small numbers means count of numbers. Are you supposed to you can say sort only 5 to 10 numbers, or you have to you can say sort 1 million numbers? Isn't it? Do you agree?
Yes, ma'am.
So that means time and space complexity that depends upon the kind of input that we have received. If the input is small, the time and space will be less. If the you can say if the input is large, and depending upon the kind of input that we have received, so we will have to change the algorithm also, because one algorithm may be faster on small data set, small input, but become very slow on the large input. So that means it depends upon the kind of input that we have received, that you can say which algorithm is best. So depending upon the kind of input, and second parameter is the contents. You can say the extent to which the items are already sorted. Isn't it? If the input that we have received, that means if it is already sorted, then if the data that we wanted to sort that is already sorted, then what will happen? Yes? Be interactive. Be interactive. If I'm asking something, you must
Ma'am,
respond.
time will be wasted.
No, that means the time will not be wasted. So, do you think all the algorithms, see if the data is already sorted, so which algorithm is best for that? What all algorithms, sorting algorithms you have studied? In the previous course, what algorithms you have already studied? Yes, Paul?
Selection sort, bubble sort, merge sort, counting sort, quick sort, Redix sort.
Oh, great. So the most of the sorting algorithms you have already studied. So what do you think, which algorithm is best for the totally sorted data?
Ma'am, maybe Redix because it doesn't compare anything.
And Nishant, what do you think?
Ma'am, Redix है also.
Okay. So, and if it is unsorted, completely unsorted, we wanted to sort the data in ascending order, and the data is there in the descending order. The input is in the descending order. Then which algo will work best? Himanshu? Himanshu, are you there?
Yes, ma'am.
Which algorithm will perform better? In the opposite scenario, where we want to sort data in the increasing order, but the input is received in the, yes?
Quick algorithm.
Quick algorithm. And who all are going to support him? Shreya? Shreya and Ritika? Shreya, are you there?
Yes, ma'am.
Are you able to recall the sorting algorithm?
Yes, ma'am.
So which
We
algorithm will perform better?
We can also use merge sort.
Okay. So what do you think? Which is better, or both will give the same performance? Yes? Ritika?
Yes,
Ritika,
ma'am.
what do you think?
Quick sort.
Why quick sort?
मैम इन मर्ज सॉर्ट हम उसको डिवाइड करके फिर सॉर्ट करेंगे तो फिर मे बी उसमें ज़्यादा टाइम लगे.
Okay. So because we are not sure, so in the today's tune we'll be doing this exercise only. So we will see that if the input that we have received, if it is the best case, what will happen, right? How many comparisons are required by a particular sorting algorithm, And if it is the worst case, so in the best as well as the worst case, how many comparisons are required, right? So we are going to do this exercise in our tube today. So we're talking about the algorithm. So what are the properties of an algorithm? When we say that this is an algorithm, what are the basic properties? So when we say the properties, so that means it should produce at least one output. When we are saying that we are trying to solve a particular problem, so in that case, the solution will provide, the solution means it is giving certain outputs. Then, so when you are writing the algorithm, you have to make sure that the statements that you write, they should not be ambiguous. So they should be precise, right? So these statements, when we are speaking, we can use the words maybe, right, might be, but when we are writing the algorithm, these such kind of words are not allowed, right? So you have to be precise, because it is telling what is the task that needs to be performed, because ultimately this algorithm you are going to convert into some code using some programming language, and in the programming you won't be able to handle the ambiguous statements. Then it should be a loop invariant. You're going to have certain loops which you have to mention precisely, that where the loop starts, what are the initial values, and when the loop will end, what are the conditions over there. So you should make it clear. So it should produce an output within a finite amount of time. So we always say you are in the 4th semester, and you know, when we are writing the program, we always expect the output to be returned that within a finite amount of time. If it is not providing the result in the finite amount of time, we say it has got in certain loop. So that means certain conditions are gone wrong, due to which it is not stopping, right? So we should get the output within a finite amount of time. So that means there is something wrong with the logic that we have developed if we are not getting the output. So it should take a finite number of inputs. So the algorithm, we should provide the limited number of inputs only for a certain range of inputs. We are trying to find out the solution when we are writing the algorithm. It should be language independent, yes. So you can say it doesn't see when you're writing a pseudocode or you're writing the algorithm. See, we write an algorithm with the help of a pseudocode, or you can write a flowchart. Both these things that you design, so they are meant to understand the logic of the problem, what kind of steps you are going to take in order to find the solution. So they are independent of the programming language that you use, whether you write the program in C, C++, Java, PHP, JavaScript, any of the programming language you talk about in the world that exists. So you can say the algorithm will remain same. That means the pseudocode you write or the flowchart you write, that will remain same, whether you convert that into C language or Java language or PHP language, in any of the, or you write it in a Python programming language. So your pseudocode or your flowchart is not going to change, because they are written to understand the logic, the solution steps for solving a particular problem, right? Then the important thing that we see that we have to discuss is the correctness. So algorithm should be correct. So what do you mean by when we say the algorithm should be correct? Who will tell me? Ronak? Ronak? Are you there? Ronak?
Yes, ma'am.
What do you mean when we say the algorithm is correct?
What, ma'am?
Correctness of the algorithm.
Correctness of algorithm. Ma'am, it depends upon time complexity.
No, correctness doesn't depend upon the time complexity. Correctness does not depend upon the complexity, how much time it takes and how much space it takes. It doesn't, it has, see, correctness is only related to the input and the output. If you have given a correct input, the algorithm should provide a correct output. Okay. So correctness only is related to the input and the output. That means if the algorithm is given the desired input, some legitimate input, or you can say some given range of numbers, in that case, it should give us the correct answer. So that means for a sorting algorithm, if you have given certain numbers, so let us say if you are given certain range of numbers, so the algorithm should give us the sorted result of these numbers. If you are doing it for the ascending order, it should give the result in the ascending order. If it is in the descending order, so the output should be in the descending order. So that reflects the correctness of the algorithm. Here we are not talking about how much time it took. Okay, so we are saying that if we have designed an algorithm to solve a particular problem, for the correct input, it should give us the correct output. Okay, so that reflects the
Yes,
correctness of the algorithm. Then why do we really need to analyze the algorithm? Yes, why do we really need to analyze the algorithm? Yes. What is the goal of the analysis? So we need to analyze the algorithm in order to understand the behavior of the algorithm. What will happen? See, analysis is required to be done in order to understand what will happen if some other input is given. So that means when we are playing with the inputs, so if the input changes in terms of size, what will happen? How we are going to get the result, how much time it is going to take, how much space it will require, how the algorithm will behave with a change in the input, right? So this is basically the main reason for you can say we do the analysis of the algorithms. So when we are analyzing the algorithm, we want to know the behavior of the algorithm, the efficiency of the algorithm, the performance of the algorithm. So while doing the analysis of the algorithm, we have two types of analysis that we do. One is posteriori analysis, another is priori analysis. Priori analysis we do using the pen and the paper, the theoretical analysis of the algorithms. Once we have learned any algorithm, once we have designed any algorithm, you can say we will try to prove on using the pen and paper that this algorithm is better than the other algorithms, or how much time it may take at max, how much time it may take to solve a particular problem, how much space it may take in order to solve a particular problem. So this we do the theoretical analysis using the pen and paper, right? And the posterior analysis we do by writing the programs. So what do? We write the program, and then practically, right, by implementing that particular algorithm, we see what is the behavior of that particular algorithm, what time it is actually taking, right, in order to provide the solution, how much space it is actually taking for executing that particular solution. So we do the analysis of the algorithm from two perspectives. One is the theoretical analysis and another is the practical analysis. Practical analysis we do by implementing that particular algorithm which we are trying to use for solving a particular problem. So we say the time complexity, that is the time measured in terms of the compile time plus the run time, and the order of magnitude, that means how the time will increase, whether the time and as well as the space, where the efficiency we are measuring in terms of time and space, how the time will change with the increase in the size of the input. Right, it is going to increase linearly or it is going to increase exponentially. So what is the order of magnitude with respect you can say of the time and space with respect to the input that we are providing. So in the next class we are going to discuss you can say the various searching and the sorting algorithms that we have touched upon today. So in the next class we'll be starting with the asymptotic analysis, and that we will do with respect to the sorting algorithms, and we will learn about the various notations. We can say if you have already done it, you can revise them again, and so that you can grasp them by their heart. So that's all for today. So I'll be taking the attendance. Be alert for your attendance.